What's poppin', dogs? Mr. Allen here. We got ourselves a doozy of a problem here with the one and only Snoop Doggy Dogg. He's designing an open-top box with a volume of 40 cubic meters. Now, the material for the square base, costs $15 per square meter, but the sides that wrap around only cost $10 per square meter. So what dimensions should the box be to keep costs below $1,000? So there's a potential to have maybe a couple different designs here. We'll see how this problem progresses. So if it's a square base, I'm going to go ahead and label this. How about X and X right here? Those dimensions are going to be the same because it's a square. But then the height of my box, we'll go ahead and just say that it's going to be H, right? H is good for height. Yeah, I like that. All right. So I know my volume is equal to length times width times height, right? My length and width are both X and X, and my height is going to be just the height, H. And what is my volume? Well, my volume here is 40 cubic meters, right? So we'll say this is going to equal 40. Okay. Let's put a pause that for a sec here. So what about my surface area? My surface area would just be adding up all my sides, right? Well, let's see here. I'd have a square base, so surface area would equal X times X, so X squared. But then I'd also have to add in, I have X by H, and I got that 4 times throughout this entire thing, right? So 4 times X times H, right? One side is X times H. There's 4 of them. Cool? Open top box. If it was a closed one, then this X squared would become 2X squared, right? But this one's open, so you can put your things in nice and easy. All right, whatever. So if I wanted to write the surface area, because my cost here is based off of the amount of material, which is surface area, right? I'm not looking for a volume here. I already know what my volume is. What I'm really looking for is the amount of material I'm going to use, and then I can factor in my price after that, right? So I need to write an area function, an area as a function of one variable. So I'm going to go with X here. I've already got this X squared, right? But then I got this 4X, and I need something for H. So swing back over to this bad boy right here. I can pretty easily solve this for H, right? I get divided by X squared, and now I have H equals 40 divided by X squared. And I can substitute that in right here. So we're going to have 40 divided by X squared. Now I have an area function all in terms of X. Let's clean it up a little bit. All right, and I am going to leave this separate for good reason. Okay, I'm going to leave them separate for good reason. I'm not going to put a common denominator and get it all into one. The reason being is because now when I write my cost function, I want my separate parts, right? This is my base. These are my sides, right? Base, sides. The cost of my base, so cost is a function of X right now. Well, the base costs $15 per square meter. So I'm going to have 15, and then we'll have my X squared. I really don't need the parentheses there, but I'm going to do that to isolate what we're talking about for the area and then our cost on the outside of that. Okay, now my next one, well, that cost is $10, right? So I'm going to have 10, and then here we have my side area total, right? So I've taken my surface area function that I had here, and I've multiplied the individual parts by their cost. So whatever the cost is associated with the base, I'm going to multiply that guy. And whatever the cost is associated with the sides, I'm going to multiply my second part. Cool? No big deal. Let's clean it up just a little bit. So now we have a nice cost function. We can bust out that TI, plug it in, and graph it. Now you can see my Windows settings there in case you need to adjust yours. It's okay if yours is a little bit different as long as you can see what I'm about to see here. And that is a portion of a rational functions graph. I'm only worried about that first quadrant there because that's where, positive dimensions are going to occur, positive volumes are going to occur, positive costs, all the stuff we want to actually look at. So what I have here is that low point. That is my minimum cost, right? But we're not asked for the minimum cost. We're asked what dimensions should the box be to keep costs below $1,000? So what I need to do now is I'm going to graph a horizontal line of y equals 1,000. And I can figure out where those two graphs intersect. So I'm going to hit second calc. I'm going to find the intersect, which is option 5. I'm going to hit enter twice to select my two curves. And then I'm going to arrow close to whichever one I want, which I will do the first one, the one that's furthest left. Hit enter. And I get 1.669, so 1.67. So let's write that down. X equals 1.67. That's one of them. And then Let's find the other intersection. All right, so I hit intersect again. I'm going to hit enter twice to select my two different curves, and I'm going to arrow over to the right one there to find that intersection. And I get x equals 7.2 this time. X equals 7.20, so 7.2. All right, so those are my two x values. But what does this actually mean? Well, let's clear out of our graph. And what we have here is that, well, x, those would be my two dimensions, right? So I'm going to have 1.67 by 1.67, but what's my height going to be? Well, I could use this handy-dandy h equals 40 divided by x squared to figure out what that would be, right? So I'm going to take that 1.67, and I'm going to square it, and I'm going to get 14.34 for my height of this one. So we have 1.67 by 1.67 by 14.34. And yes, I am using that rounded value there because whatever material I'm using here needs to be factored in this whole thing. I don't want the continuation of decimals to mess something up or whatever. So it is okay in that case, in my opinion, to use that rounded 1.67 to find my height. All right, let's do the same thing for the other one. I'm going to take 40. I'm going to divide it by 7.2 squared. And I'm going to get 0.77 for my height. So I'm going to have a really shallow box here. 7.2 by 7.2 by 0.77 meters. All right, that's it. A little bit crazy, kind of tricky, you know, writing that cost function, all those other things. But hey, we rocked it. It was dope, and that's awesome.